The outbreak began at midnight. The AI had already mapped it by dawn. Epidemiologists are the detectives of disease, the scientists who track how illness spreads through populations, identify risk factors, design public health interventions, and prevent the next pandemic. They are the quiet guardians of global health. But artificial intelligence is now scanning patient records in real time, predicting disease outbreaks weeks before they surface, and modeling transmission dynamics faster than any team of researchers. So, is the epidemiologist facing an AI revolution? And what does this mean for the public health scientist working in the field today? Let us start with what AI is already doing in the world of epidemiology. Machine learning algorithms are analyzing satellite imagery, social media data, weather patterns, and electronic health records simultaneously to detect the early signals of disease outbreaks, sometimes weeks before traditional surveillance systems raise the alarm. Blue Dot's AI platform identified the COVID-19 outbreak in Wuhan 9 days before the World Health Organization issued its first public warning. AI-powered genomic sequencing tools are tracking pathogen mutations and transmission chains at a scale and speed that was impossible just 5 years ago. During the COVID-19 pandemic, platforms like NextStrain used AI to map thousands of viral variants in near real-time, work that would have taken epidemiologists months using conventional methods. Predictive modeling platforms are now using AI to simulate the spread of infectious disease across populations, accounting for mobility data, vaccination rates, demographic profiles, and healthcare capacity, producing scenario forecasts that inform government policy decisions within hours. AI natural language processing tools are mining published literature, clinical reports, and news feeds across multiple languages to identify emerging health threats, performing systematic literature surveillance that would require teams of researchers working for months. Automated contact tracing systems, wastewater surveillance AI, and syndromic surveillance platforms are replacing the manual data collection and analysis that epidemiologists have historically spent significant portions of their working hours completing. But here is where the epidemiologist remains absolutely irreplaceable. The interpretation of epidemiological data in its full social, political, and cultural context is a deeply human skill. AI can identify a pattern in mortality data, but it cannot understand why a community distrusts a vaccine, how poverty drives disease burden, or why an intervention that works in one country will fail in another. That contextual intelligence belongs to the epidemiologist. Study design, ethical governance, and causal inference remain the domain of trained scientists. AI can process data, but it cannot design a randomized controlled trial, navigate an institutional review board, or weigh the public health ethics of a quarantine policy. These decisions require the judgment and accountability of a human expert. Field epidemiology, the boots-on-the-ground investigation of outbreaks in complex, resource-limited, and politically sensitive environments, requires skills that no algorithm possesses. Building trust with communities, negotiating with governments, and adapting methodology in real time to circumstances on the ground is irreducibly human work. Epidemiologists who develop expertise in AI-assisted surveillance systems, genomic epidemiology, causal machine learning methods, and global health policy will be among the most powerful public health scientists in the world. And those who combine deep quantitative expertise with field experience, community engagement, and policy translation skills will be genuinely irreplaceable, because AI needs humans to ask the right questions, interpret the answers, and take the right action. So, will epidemiologists be obsolete by 2030? The reality is this: routine data collection, basic descriptive surveillance, and standard report generation will increasingly be automated, reducing the need for large teams performing manual epidemiological data processing. However, the demand for expert epidemiologists is not declining. The COVID-19 pandemic demonstrated with brutal clarity that the world is chronically underinvested in public health capacity. The WHO has identified a critical global shortage of epidemiological expertise, particularly in low- and middle-income countries. Climate change is expanding the geographic range of vector-borne diseases. Antimicrobial resistance is creating new epidemic threats. Chronic disease burden is demanding population-level intervention at scale. AI will generate the data, but epidemiologists will be needed to translate it into policy, direct the response, and protect populations. Those most at risk are epidemiologists performing purely administrative or low-complexity surveillance functions without developing advanced analytical or field expertise. By 2030, the outbreak investigation will look very different. AI will have flagged the signal. The models will have run overnight. But the epidemiologist will still be the one who walks into the community, asks the right questions, and designs the intervention that actually saves lives. AI is not replacing the epidemiologist. It is giving them the most powerful surveillance system ever built. The future of public health is not the algorithm or the dashboard. It is the scientist who knows how to use both.